Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at calculating percentage of a quantity. So in the previous lesson, we looked at one quantity as a percent of another. In the previous lesson, we were calculating the percent. This time, we know the percent and are using it to calculate a quantity. So you just follow these two steps here to find the percentage of a quantity. Convert percentage to a fraction or decimal, either one doesn't matter, and then multiply by the quantity because of means times. Let's look at an example. Class of 25 students, 64% were born in Australia, 25% of them were born in Tasmania. How many students were born in Tasmania? So here we know the percentages and we're calculating a quantity, in this case how many students. So let's first start by calculating how many students were born in Australia. So 64% of 25. To calculate this, you convert the percent to a fraction or decimal, doesn't matter which one. Now of means times, and then you times by the quantity. You don't need to simplify this fraction here because we're using it in a calculation. So putting that in a calculator, you get 16. So 16 students were born in Australia. So of those 16, 25% of them were born in Tasmania. So convert the percent to a fraction or decimal, either one, doesn't matter, and then times by the quantity, you get 4. So 4 students were born in Tasmania. All right, let's now look at percentage increase and decrease. So when you are performing a percentage increase or decrease, use these two formula here. Note the only difference between them is plus when you're increasing, minus when you're decreasing, and also note that R here refers to the percentage by which you're increasing or decreasing. So let's look at this example here. TV normally costs $440. Price marked up by 40%, new price discounted by 40%, and we're going to calculate the overall percentage change. So there are a few steps in this, but let's start by taking the price and increasing by 40%. So to do that, you take the amount and you times by 1 plus R over 100. R is 40 in this case because we're going up by 40%. So what are we actually doing here? 1 plus 40 over 100 is 1.4 or 140%. If you're increasing by 40%, you're taking 100%, the whole lot, adding another 40%, you've now got 140%. So we are essentially finding 140% of 440. So if you put that on your calculator, you get 616. So that's what the TV will cost after the markup. So now what we're going to do is take that 616 and discount or decrease its price by 40%. So it's going to be 1 minus 40 over 100 this time. 1 minus 40 over 100 is 0.6. Essentially what we're doing here is finding 60% of 616. If you have 100%, like a whole, and you take away 40%, you're left with 60%. So this is what the TV will cost after the discount. Note that we haven't returned to the original price of $440 because when we increased by 40%, we were increasing by 40% of a smaller number. So the amount by which we increase is not as big as how much we decreased. So if we want to calculate the percentage change, remember this formula. We go change divided by the original times 100 and stick a percent sign on the end. So the total change in price from 440 to 369.60, it's gone down by $70.40. So that's the change over the original was 440. Then we times by 100 and stick a percent sign on our answer. Now putting that in our calculator, we get 16%. It turns out it wouldn't matter the original starting price. We would get the same final answer of 16%. And that is because when you times a number by 1.4 and then times that number by 0.6, so you increase by 40%, decrease by 40%, you would get 84% of the original, which is a discount or decrease of 16%. That would work even if this was $1 million. So increasing a number by 40% and decreasing the new number by 40% doesn't get you back to where you started. All right, let's now look at another question involving percentage increase and decrease. So price of an item increased by 5%. By what percentage must we discount the new price to return to its original? Spoiler alert, it is not 5%. Let's start by letting X equal the original price. We don't know what that is. It could be anything. We'll get, in fact, the same answer regardless of the original price. So if we increase the original price by 5%, we're going to take it and multiply by 1 plus r, in this case 5 over 100. So after we've increased by 5%, the new price will be 1.05x. So in order to return to the original, we need to subtract 0.05x, because 1.05x minus 0.05x gets us back to 1x, gets us back to the original price. So we just looked at the percentage change formula on the previous slide. The percentage change formula is the total change, so that's the total change we need to go down by, divided by what you started with, the original, and then times by 100, add a percent sign on. So of course we can cancel out the x's, we can put the rest of this straight in our calculator. So putting that in our calculator, we should get about 4.7%. So it's a little less than 5%. As we sort of learned on the previous slide, if you increase a number by 5%, decrease the new number by 5%, you're going to be slightly less than where you started with. All right, let's now look at finding the original. So in all our examples, whether it be calculating percent of a quantity or increasing or decreasing by a given percentage, we've always multiplied. When you're finding the original amount, you divide. So let's look at an example where you're finding the original amount. So 32% of students at a school have blonde hair, total of 720 students have blonde hair. How many students attend the school in total? So why is this one asking us to find the original amount? Well, it's not asking us for 32% of 720. What it's saying is there is some total number of students at the school, we don't yet know. When we take 32% of that, we get 720. So we know that of means times, and 32% is 32 over 100. So this is the equation we have. Of course, if I want to get the box, if I want this by itself, I undo timesing 32 over 100 by dividing 32 over 100. So this is why we divide when we're finding the original amount. So you can put this straight on your calculator and you get 250. We're finding the original amount. We're saying what number do you start with, and take 32% of it to get 720. So this one we were finding the original because we already knew the number after the percentage was applied. We wanted to find the number before the percentage was taken. All right, let's now look at one more example. So cost of a shirt discounted by 34% now costs $59.40. Calculate the original cost of the shirt. So once again, we're finding the number we needed to start with that had some percentages done to it. So what we know is if we let this original cost be X, if we discount a number by 34%, we times by 1 minus 34 over 100. That's how you discount by 34%. And then after we do that, we should be left with 59.40. So if I want X by itself, all I need to do is take my final price, and rather than timesing, I divide. So it's still 1 minus because it was discounted. So if you put that on your calculator, you get $90. If you take $90 and you discount by 34%, you end up with $59.40. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.